Hello and good day everyone. I am Supriya Gupta Bani, Assistant Professor at Ramdev Baba College of Engineering and Technology, Nagpur, here to present the new topic that image segmentation. So, we are going to discuss the image segmentation part with thresholding algorithm and discuss its technique and application to you. Now, what is image segmentation? So, group similar components such as pixels in an image frame in a video to obtain compact representations. Now, what's its applications? Finding tumor, veins, in medical images, finding targets at satellite area, images finding people, surveillance images, summarizing videos, etc. These are the application of image segmentation. So, moving further with the technologies of image segmentation, we are going to use the thresholding values. The methods are thresholding and k-means clustering, etc. We are going to discuss these things with you, that what the thresholding and clusterings are doing for further enhancement in image segmentation. So, the image segmentation algorithm for monochrome images generally are based on one or two basic properties of grayscale value. Now, what is grayscale value? Whenever we convert the images in gray values like 0 to 255 grayscale images, that is called the grayscale values. Two basic points are discontinuity and similarity. Now, what is discontinuity? The approach is to partition an image based on abrupt changes in grayscale level. The principal areas of interest within this category are detection of isolated point, lines and edges in an image. Now, what is the similarity? The principal approach in this category are based on thresholding, region growing and region splitting and merging. Coming up to the basic topic, that is thresholding, what is the assumptions on that? The range of intensity level covered by object of interest is different from the background. Whenever we are going to use this thresholding, what we do? We have to cover our foreground and background detection. Means what is your object and what is its background, we can say. Here is the formula, that is g of xy is equals to 1 if f of xy is greater than t, where t is the threshold value. Otherwise, this detects as 0 if f x of y is less than equals to t, that is again threshold value. So, if your function value is getting higher side of threshold point, you can take it 1 as your object of foreground. Otherwise, you can take the pixel values as 0 if it is getting the less or equals to the threshold point, and in this way the thresholding would work to dispute or distract the background and foreground from the levels. Again, we can see here in the image there, the foreground image value of intensity of the pixels is different and the foreground background image is going to show us the different intellectual image pixels. In this image, we can see there is a black background and gray scale level foreground, where we can see in the histogram plotation, the high level histogram would be created as background and the low level histogram created as a foreground image, that is converted into gray level images. Again, we can see here, when we get a thumb impression, we have to cover it with the background and foreground images. Firstly, the background is converted in the grayscale images and then we differentiate with the threshold value that the foreground is black and the background is gray. When we decided it, the thumb impression is clearly visible as foreground and the background is clearly visible as a gray level. So the histogram plotations are also going to display us the basic global thresholding value, where we can see the low level thresholding is showing as background and the high level thresholding, that is showing as a black images, that is for the foreground or our thumb impression object. Yeah. Now the another challenge is basic adaptive thresholding, where we cannot compromise with the pixel images when we cannot differentiate the exact gray level values. So the basic adaptive thresholding is work here, where we can use the different type of histogram using the pixel images and convert this gray level values and main object pixel values into foreground and background. Here we can see in basic adaptive thresholding, we are going to justify the background image and foreground image with the histogram, where the squared are present in the figure is showing a similar type of pixels using the intensity value and find the foreground as well as a background, where we can use optimal global and adaptive thresholding. This method treats pixel values as probability density function. The goal of this method is to minimize the probability of misclassifying pixel as either object or background. There are two types of error here: mislabeling an object pixel and background, and mislabeling a background pixel as object. It means you can say the two types of error always arise whenever you going to divide this in foreground and background. You have to convert these values in exact intensity or exact probability density functions, so that we can find this pixel is for foreground and the upcoming pixel is for background. Now here we can see in this figure the gray probability density function is showing clearly two pixel points, that is P1Z and P2Z. The P1Z is for clearly stated, that is background, and P2Z is clearly stated that it is a foreground, because we have defined it here T as threshold. So the threshold value is going to decide which pixel is going to for background and which pixels are coming for the foreground process. In this blur picture, we cannot find what is giving us as foreground and background. Then how can we segment this image? So we are going to use the boundary characteristics for the image, where we can see here the boundary characteristics are measured as line by line, and we can see the foreground image is totally converted in white and the background image is clearly defined. So we have find all the signatures, all the handwritings from this checkbook as a foreground or object image. Now what is basic thresholding? Suppose that an image f of xy is composed of light object on a dark background, and the following figure is the histogram of the image. Then the object can be extracted by comparing pixel values with a threshold point t. Here in the image we can see the object is in black, or majorly we can say the higher range of intensity value, and the background is again in the values of gray level. So how can we detect which is the foreground and which is the background by the thresholding values? We have to plot the histogram of this image, where we can see the first histogram is in very low level, which can be generated as a gray level values for background, and higher side of histogram values can be generated as black or majorly intense values of the pixel. Again this image is showing us the thumb impression, where we can see the background is total white and the thumb impression is in the black points. So, these white and black points can be described as foreground and background, where we have taken the foreground as high intensity 0 to 255 values with background with the low intensity or grayscale values of background. Here the histogram is also saying that the low level values are connecting with the background process and the foreground process is connecting with the high level intensity value, that is showing our thumb impression. It is also possible to extract objects that have a specific intensity range using multiple thresholds. Extension to color image. Straightforward, there are three color channels, in each one specify the intensity range of the object. Even if the objects are not separated in a single channel, they might be with all the channels. Application example is detecting, tracking face based on the skin color. So, the colored image are going to use as segmentation with this thresholding is very popular when we are going to use this threshold point in multiple threshold conversion. Non-uniform illumination may change the histogram a way that becomes impossible to segment the image using a single global threshold. So, that is why we are going to use a multiple threshold values for connecting these types of noisy or this type of images which have non-uniform illumination. Choosing local threshold value may help for this. Here we can see that multiple pixels are not showing us the exact foreground or background images. So, that is why we are taking local exact threshold values and multiple threshold values to connect the foreground and background images in clear picture. Whenever we plot the histogram for these, we can see the gray level images are converted into different histogram and the dark pixels, that is in background process, we can find this clear picture for foreground and background processes. Here we are going to use the adaptive thresholding, where again we are converting our images into the subplots. These subplots are going to convert your image in foreground and background process. Again, this is plotting your histogram in the level of 0 to 255 grayscale level, and this decided that which intensities are going to use to form the background and which pixels of intensity are going to use or produce your foreground. Now, this picture almost are similar for illumination process, where we have to separate these pictures with adaptive thresholding as well as the global thresholding values. Again, we have to convert the images into subplot and then plot the histogram for the same image. Then you can find the background and foreground with the both thresholding points. Thresholding is a simple and efficient technique to perform basic segmentation in an image, and to binarize it. Binarize means turn it to binary image, where pixels are either 0 or 1, and if you are using gray levels, then it is 0 to 255 integrates that represents them. Typically, you are used thresholding to perform simple background and foreground process segmentation in an image, and it boils down to variance on a simple technique for each pixel. So, now we are going to use the Python code for this thresholding values to convert the image into partition of background and foreground. Here we have taken if pixel value is greater than threshold value, then the pixel value is maximum, else we have to set this pixel value as 0. Another way to overcome some of these issues with basic thresholding with a single threshold value is to use adaptive thresholding. which applies a threshold value on each small region in an image rather than globally. So, the adaptive thresholding is ever better. We have to find the foreground and background images from the input image. Simple thresholding with using OpenCV. Whenever we have applied the Python code with OpenCV, we have to go with the Python API process. So, thresholding in OpenCV, Python API is done via cv2.threshold. This method, which accepts an image numpy array represented with integers. The threshold maximum values and threshold method is going to use here. How the threshold and maximum values are finding, we can see here with the code. Here we can see in the code that image is converted with the cv2.imagePointObject, that is JPG form. So, we are going to load our image in Python code with this line, and image is equals to cv.colorImage cv.color to RGB. If we are finding the color image, so we are going to plot this line for color image. Now, we have taken the blurred is equals to cv2.Gaussian blur image. What is doing this blur image? That function is done that some blur points are going to take a noise values and remove this noise value with blurring the image. So, we are loading image, we are converting the gray level images, and we are going to blur the noisy image from the input image. Then the return code is just applied the threshold value. Here we have to print f threshold return, where we find the threshold values here. Here, since the threshold is 220 and we have used the threshold binary method, every pixel values above 220 will be increased to 255, while every pixel's value below 220 will be lowered to 0, because we have to find higher threshold value, otherwise it is not met with the threshold value, then we are converting it to 0, creating a black and white image with a mask converting the foreground object. Let's plot the results. OpenCV window can be a bit funky, so we'll plot the original image, blurred image, and results using matplotlib. Here we can see the code where figure is in axis point and axis plot is PLT subplot, where figure size is 12:8, that is 2D image. Again we are going to use that image show in image form, image show in blurred form, and image show with the mask process. As mentioned earlier, there are various ways you can use the threshold and maximum value in a function. We have taken a look at the binary threshold initially. Let's create a list of methods and apply them one by one, plotting the results. Here we can see where we are going to load the image, where we can convert the gray level images, where we can blur the images to reduce the noises, and then we have applied here the methods of thresholding and convert the image with the threshold method to find the foreground and background images. Threshold binary and threshold binary inverse are inverse of each other and binarize an image between 0 and 255, assigning them to the background and foreground respectively and vice versa. Threshold trunk binarizes the image between threshold and 255. Threshold 20 and threshold 20 inverse binarize between 0 and the current pixel values. SRCXY. Let's take a look at the resulting images. Here the first would be the input image, the second is for gray level images, and the third is using the binary threshold value, where we can clearly state that the background images are converted as a black image and the foreground images are yellow colored pixels. Again, similar pixel we have to do for inverse binary threshold. Again, first would be the input image, second would be the gray level converted image, and third would be inverse binary threshold, where we can see the background of the images is set as white and the foreground objects of coins are seen as light blue pixels. These methods are intuitive enough, but how can we automate a good threshold value? And what does a good threshold values even mean? Most of the results so far had not idle masks with marks and sparks in them. This happens because of the difference in the reflective surface of the coins. They are not uniformly colored due to the difference in how rich reflect light. We can to a degree better this by finding a better global threshold. Automatic optimized thresholding with OpenCV. Now, how to decide which threshold is optimized can be seen with this OpenCV. OpenCV employs two effective global threshold searching methods. First one is OTSU method and the triangle method. OTSU method assumes that its work on bimodal images. Bimodal images are image whose color histogram only contains two peaks, has only two distinct pixel value. Rather it is black or white, or if you are converting it into gray level image pixels, it would converting only the containing two peaks of the pixel values. Considering that the peaks each belong to a class such as a background and a foreground, the ideal threshold is right in the middle of them. Now here we can see the picture where the input image is clearly showing the gray level values, and we have to convert these pixel values into only two peak of values, where we can see the picture is converted in totally black and white level of images, where we can see the black is set as a background and the white is set as a foreground. While we are plotting the histogram, again we can see the threshold is lie between these two peak pixel point, and the histogram is again plot for the foreground and background processes. So, the background pixels are similarly created a single histogram and foreground pixels are created a single histogram. You can make some image more bimodal with Gaussian blur, but not for all. All alternative algorithms in the triangle algorithm, which calculates the distance between the maximum and minimum of the gray level histogram and draws a line. The point at which that line is maximally far away from the rest of the histogram is chosen as the threshold. There is no competition between them. They each work on different types of images. So, it's best to try them out and see which returns the better results. Both of these assume a gray-scaled images, so we'll need to convert the input image to gray via cv2.cv color. Now, in this Python code, we can see cv2.cv color image convert the picture into gray level scale. Then we are going to use the blurred image with the Gaussian blur image that could be containing the noisy image or noisy object in your image. The blurred image can be removed this noise from your input image. Then we have to convert the mask 1 with CV2 threshold blur with thresholding OTSU method and mask 2 converting the threshold image with threshold triangle. Let's run the image through with both method and visualize the results. Here the code for both the methods where we are converting our images into grayscale, we are going to blur our noisy image, we are going to subplot the Otsu and triangle images. First output is showing for Otsu method where we can see first was in the input image, second one is converted grayscale image and third one is showing the results of Otsu method, that is using the threshold value converting only two peak point 0 or 1, likewise black or white backgrounds. So coins are effectively showing with the Otsu method. Now this is the triangle method where we can see the input image, the grayscale level images and finally the output from triangle method of thresholding. We cannot find exactly what is the coins are giving us in the foreground. However, it's clear how to triangle method was able to work with the image and produce a more satisfactory results. Here, the triangle method outperform Otsu method because the image isn't bimodal. Now, the limitation of OpenCV thresholding. OpenCV thresholding is simple, easy and efficient, yet it's fairly limited. As soon as you introduce colorful image element, non-uniform backgrounds and changing lighting conditions, global thresholding as a concept becomes too rigid for this. Images are usually too complex for a single threshold to be enough, and this can partially be addressed through adaptive thresholding, where many local thresholds are applied instead of a single global one. While also limited, adaptive thresholding is much more flexible than global thresholding. Now, in conclusion of thresholding, in recent years, binary segmentation like what we did here and multi-level segmentation, you can have arbitrary number of classes encoded, has been successfully modeled with a deep learning networks which are much more powerful and flexible. In addition, they can encode global and local context into the image they are segmenting. The downside is you need data to train them and as well as time and expertises. For one of the fly simple thresholding, you can use OpenCV. For accurate production level segmentation, you'll want to use neural networks. Now the another method that is going to partition your data, that is k-mean clustering. Partition the data points into k clusters randomly, find the centroids of each clusters for each data points. Calculate the distance from the data points to each clusters. Assign the data points to the closure clusters, then recompute the centroid of each cluster. Repeat step 2 and 3 until this is going to further change in the assignments of cluster points or in the centroids. Here in the figure we can see the two data points are there and we have fixed the two centroids here for red and green. Again we are converting the distance based data points in the two centroids values. The distance would be changes again with the two level or data points with the distance value. Finally, we are going to convert these two cluster data points as a similar cluster data points. So, with this process, we are going to make the clusters of similar intensity values, like we are converting the threshold values in foreground and background process. Similarly, from this k-means clustering, we are going to produce two classes, that is foreground and background. Again, this is the example of k-means clustering where we have multiple types of data points and we have to set multiple centroids to create the similar intensity value of clusters with the similar type of pixel. Here we can see the RGB vector which is converting the gray level values with RGB, that is red, green, blue colored images, and we have to convert this colored image with RGB vectors and finding the threshold value or k-means clustering to finding the background and foreground with the another clusters. In this example, we can see in pictures we have to find the clusters images to find the similar type of pixels. So, the skin color is generated a single cluster, the blue color ring pixels are generated another clusters, and the background is situated as black, that is again a single cluster. So, we can find in 3 clusters formed with the pixel values. Here again we can see the original image, then again the k is equals to 5 means 5 number of clusters are there, and k is equals to 11 where 11 number of clusters are using to this image converting similar type of pixels. These going images are produces the different type of pixel values are approaching the another clusters, and we can find how the object is different from the another object. So, the cluster is a very powerful tool to decide which type of pixels are converting in single clusters. Again, this image is finding foreground and background images of the major image or input image, and we can see the clusters are making with 2-point clusters that could be black and white for the foreground and object clusters. Now, feature of different types of clusters may have different scales. For example, pixel coordinates on 100 cross 100 images versus RGB colored values in the range of 0 to 1. What is the problem for this? Features with larger scale dominates clustering. What is the solution for it? Scale the features. Whenever we scale the features, it could be maximize the optimized value of pixel that can be converted into gray level images and that can converted in the exact 2 type of or 2 peak values of pixels with clustering or thresholding values. Limitation of thresholding. A uniform threshold may not apply across the images. It measures the uniformity of regions in some sense but doesn't examine the inner relationship between region. Local disturbance can break up the nominally consistent regions. These are the limitation of thresholding, but I am concluding my lecture. What is thresholding is going to use with segmentation, that the thresholding is clearly converted the pixels in the 2 peak forms like 0 to 1 or 0 to 255 grayscale images. Rather, you can convert it with RGB values also. So, the thresholding is converting your object as a foreground and the rest of the things as a background. So, you can clearly visible your object detection or object segmentation from your background. Thank you.